May 26, 1942. The Libyan desert east of Tobruk. British tank commanders watched American armor roll off transport ships and wondered if someone at the War Office had lost their minds. The vehicles standing before them looked like engineering mistakes. 10 feet tall, a 75mm cannon jutting from the right side of the hull, a smaller 37mm gun perched in a turret on top, two guns pointing in different directions, a silhouette so tall that every enemy gunner within 5 miles could see it coming. The British crews assigned to these machines called them Grants. The Americans who built them called them Lees. Everyone who first saw them called them ugly, but within weeks, these ungainly machines would accomplish something no British tank had managed in 2 years of desert warfare. They would trade blows with Rommel's Panzers and win. The M3 medium tank was never supposed to exist. It was a stopgap, a compromise, an admission that American tank design had fallen dangerously behind. And yet this awkward, towering, apparently obsolete machine would prove critical to Allied survival in North Africa. It would fight in Burma until 1945. It would kill more enemy armor than any tank the British had fielded before it. This is how American engineers turned a desperate improvisation into a weapon that changed the war. By 1940, American tank doctrine faced a problem it had ignored for years. The German army had just conquered France in 6 weeks, using armored divisions equipped with tanks mounting 50mm and short 75mm guns. American tanks carried 37mm cannons. The gap in firepower was not subtle. The 37mm M6 gun could penetrate roughly 36mm of armor at 500 yards. German Panzer III and IV tanks carried frontal armor ranging from 30 to 50mm and growing thicker with each new variant. The mathematics were unfavorable. American tanks could hurt German tanks only at close range, under ideal conditions. German tanks could destroy American tanks at virtually any combat distance. The solution seemed obvious: mount a bigger gun. The Army had a 75mm M2 cannon derived from the famous French 75 field gun. This weapon could penetrate 60mm of armor at 500 yards. It fired a high explosive shell weighing 14.7 pounds compared to the 37mm shell at 1.9 pounds. Against infantry, fortifications, and anti-tank guns, the 75mm was 7 times more destructive. But mounting this gun created an engineering problem that seemed impossible to solve quickly. The 75mm M2 gun was 5 feet long. It required a recoil system that added another 2 feet. The gun crew needed space to load, aim, and operate the weapon. A conventional tank turret large enough to hold this gun, its recoil mechanism, ammunition storage, and crew would require a turret ring diameter of at least 69 inches. The M3 Stuart light tank had a turret ring of 47 inches. The medium tank, then under development, eventually designated the M4 Sherman, needed a completely new hull design to accommodate the required turret ring. That design work would take at least 18 months. The German army was not going to wait 18 months. In July 1940, the Ordnance Department made a decision that violated every principle of tank design. They would mount the 75mm gun in the hull. The concept was not new. The French Char B-1 had mounted a 75mm gun in its hull throughout the 1930s. But the Char B-1 was widely considered a failure precisely because hull-mounted guns created severe tactical limitations. A tank with its main gun fixed to the hull could only aim by turning the entire vehicle. In combat, this meant slow response times, difficulty tracking moving targets, and vulnerability while maneuvering. American engineers accepted these compromises because they had no alternative. The existing M2 medium tank chassis could be modified to carry a hull-mounted 75mm gun relatively quickly. A smaller 37mm gun in a conventional turret would provide the ability to engage targets without repositioning the entire tank. The design was ugly. The design was impractical. The design could enter production within months instead of years. Rock Island Arsenal began work in August 1940. The first pilot vehicles rolled out in January 1941. The initial design featured a riveted hull, a cast turret for the 37mm gun, and a small cupola on top of the turret mounting a 30 caliber machine gun. The crew numbered 7 men, reduced to 6 in later production variants. The specifications were impressive, despite the awkward configuration. Combat weight reached 30 tons. The Continental R975 radial engine produced 400 horsepower, giving a top speed of 26 miles per hour on roads. The Wright R975 variant used in later models produced the same power with improved reliability. Armor protection ranged from 38mm on the front hull to 51mm on the turret. The 75mm M2 gun, later upgraded to the M3, could penetrate 60mm of rolled homogeneous armor at 500 yards using standard armor-piercing ammunition. The 37mm M6 gun in the turret provided a secondary capability against lighter vehicles and was adequate against Japanese armor throughout the Pacific War. The tank carried 46 rounds of 75mm ammunition, 178 rounds of 37mm ammunition, and over 9,000 rounds for its machine guns. A crew could sustain combat operations for extended periods without resupply. Production began at American Locomotive Company in August 1941. Chrysler, Baldwin, and Pressed Steel Car Company joined the production effort within months. By December 1941, factories were producing M3 tanks at the rate of several hundred per month. The British Army needed tanks desperately. Their indigenous designs, the Crusader and Valentine, mounted 2-pounder guns firing 40mm shells. These weapons proved increasingly inadequate against German armor in the Western Desert. The Crusader weighed 19 tons and could reach 43 kilometers per hour, but its armor maxed at 49mm and its gun could not penetrate the frontal armor of a Panzer III at combat ranges. Under Lend-Lease, Britain requested American medium tanks immediately. But the British had specific requirements that differed from American doctrine. British tanks carried crews of 4. The M3 required 6 or 7. British radio equipment operated on different frequencies with different dimensions than American sets. Most importantly, British tank commanders wanted the commander stationed in the turret with access to the main armament, not isolated in a hull cupola observing through periscopes. The solution was the M3 Grant, a modified version of the M3 Lee produced specifically for British service. The Grant eliminated the hull cupola entirely. A new cast turret, longer and lower than the American version, accommodated the radio equipment and provided the commander a position with direct oversight of the 37mm gun. The distinctive shape of the Grant turret became the recognition feature that distinguished it from the American Lee variant. The first Grants arrived in Egypt in early 1942. British crews, despite their initial skepticism about the tall silhouette and unusual configuration, quickly recognized what the 75mm gun represented. For the first time, they had a tank that could fire high explosive shells effective against infantry positions, anti-tank guns, and fortifications. For the first time, they had armor-piercing capability comparable to German tanks. May 26, 1942. Rommel launched Operation Venezia, his offensive to capture Tobruk and drive the British from Libya. His Afrika Corps fielded approximately 330 tanks, including 160 Panzer IIIs and 40 Panzer IVs. The Panzer III mounted a 50mm gun capable of penetrating 70mm of armor at 500 meters. The Panzer IV carried a short 75mm gun optimized for infantry support. The British Eighth Army deployed roughly 700 tanks, including 167 M3 Grants, organized into the 4th Armored Brigade. This was the first major engagement where the Grant would prove its worth. The initial German assault swept around the southern end of the British defensive line at Bir Hakeim. Rommel expected to roll up the British positions within days, as his forces had done repeatedly since 1941. But the Grants changed the calculation. At Bir el Harmat, on May 27th, the 4th Armored Brigade engaged elements of the 21st Panzer Division. British after-action reports recorded that the Grant's 75 mm gun consistently hit German tanks at ranges of 1,200 yards. The Crusader's 2-pounder was effective only within 600 yards under optimal conditions. Rommel's tank commanders suddenly faced opponents who could hurt them before they could close to effective range. The tactical impact was immediate. German units that had grown accustomed to closing with inferior British armor and destroying it at will now took significant casualties during the approach. The 21st Panzer Division reported losing more than a third of its tanks in the opening days of the offensive. While the Grants could not reverse the overall German advance, they inflicted losses at rates the Afrika Korps had never experienced against British armor. The Battle of Gazala ultimately ended in British defeat. Tobruk fell on June 21st, but the performance of the M3 Grant demonstrated that American armor technology could compete with German designs. The 75mm gun had proven itself. The question was no longer whether American engineers could build effective tanks. The question was how quickly they could build enough of them. Production of the M3 Lee and Grant reached 6,258 units between April 1941 and December 1942. American Locomotive Company built 4,724. Baldwin Locomotive Works produced 295. Pullman Standard Car Company manufactured 500. Pressed Steel Car Company added 539. Detroit Tank Arsenal contributed 200. Of this total, approximately 2,800 went to British and Commonwealth forces under Lend-Lease. The Soviet Union received 1,386 M3 Lees, where the tanks fought on the Eastern Front through 1943. The remainder equipped American armored divisions during their training and deployment phases. The British variants included not only the Grant, but also specialized versions. The M3 hull served as the basis for the M7 Priest self-propelled gun, which mounted a 105mm howitzer and became one of the most successful American artillery vehicles of the war. The M31 tank recovery vehicle used the M3 chassis to recover damaged tanks from the battlefield. The Canal Defense Light mounted a powerful searchlight for night combat operations. By late 1942, the M4 Sherman began entering service in significant numbers. The Sherman featured the same 75mm gun in a proper turret, reducing the height of the vehicle and eliminating the tactical compromises inherent in the M3 design. Production of the M3 ended in December 1942, but the tanks already built continued fighting for years. If you are finding this examination of American engineering useful, consider subscribing. It helps the channel produce more content like this. The M3 Lee's effectiveness becomes clear when examined against its contemporaries. Against the German Panzer III AOSFJ, the dominant German medium tank of 1942, the M3 held significant advantages. The Panzer III weighed 23 tons to the M3's 30. The German tank's 50mm Kobugo K 38L/42 gun penetrated 67mm at 500 meters. The M3's 75mm M3 gun penetrated 60mm at the same range. On penetration alone, the weapons were roughly comparable, but the 75mm fired a high explosive shell weighing 14.7 pounds. The 50mm high explosive round weighed less than 2 pounds. Against infantry, anti-tank gun positions, fortifications, and soft targets, the American gun delivered 7 times the destructive effect. This capability transformed tank operations. M3 crews could suppress enemy positions, support infantry advances, and destroy obstacles that smaller caliber guns could not affect. Armor protection slightly favored the M3. Frontal hull armor of 51mm on the M3 compared to 50mm on the Panzer IIIJ. The M3's height, at 10 feet 3 inches, made it easier to hit than the 8 foot 5 inch Panzer III. But visibility from the M3 was superior, and the larger crew could maintain awareness in all directions simultaneously. Against British tanks, the superiority was dramatic. The Crusader Mark III mounted a 6-pounder gun with 57mm bore, but this weapon entered service only in mid-1942. Earlier Crusaders carried the 2-pounder with 40mm bore, penetrating 40 millimeters at 500 yards. The M3's 75mm gun offered 50% greater penetration and exponentially greater high explosive capability. The Valentine infantry tank carried the same 2-pounder until late variants received the 6-pounder. At 65 millimeters, the Valentine had thicker frontal armor than the M3, but its top speed of 15 miles per hour meant it could not keep pace with mobile operations. The M3 combined medium tank mobility with heavy tank firepower. Against Japanese armor, the M3 was overwhelmingly superior. The Type 97 Chiha, Japan's primary medium tank, weighed 15 tons and mounted a 47mm gun. Its armor reached 33 millimeters at maximum. The M3 could destroy the Chiha at any combat range while remaining nearly impervious to Japanese tank fire, except at very close distance. The M3 Lee found its longest service in the China-Burma, India theater, where 1,700 vehicles equipped British, Indian, and Chinese forces through 1945. The Burma campaign demanded exactly what the M3 provided. The terrain consisted of dense jungle, narrow roads, fortified Japanese positions, and limited opportunities for armored maneuver. The 75mm gun excelled at destroying bunkers and fortifications. The tall silhouette that was a liability in open desert became less significant in restricted jungle terrain where engagement ranges rarely exceeded a few hundred yards. The 3rd Indian Motor Brigade and later the 25th Dragoons operated M3 Lees in Burma from 1943 through the end of the war. These units supported infantry advances through some of the most difficult terrain on Earth. Japanese anti-tank weapons, primarily the 47mm Type 1 gun, struggled to penetrate the M3's frontal armor at typical jungle engagement distances. At the Battle of Imphal in March through July 1944, M3 Lee tanks helped break the Japanese offensive against India. The tanks destroyed bunker complexes, provided direct fire support for infantry assaults, and proved virtually immune to Japanese infantry anti-tank tactics. The Type 97 Chiha medium tanks the Japanese deployed could not match the M3 in firepower, armor, or crew survivability. The M3 remained in frontline service in Burma until the Japanese surrender in August 1945. By that point, the tank was obsolete by European standards, but still overwhelmingly effective against Japanese opposition. No replacement occurred because no replacement was needed. The Soviet Union received 1,386 M3 Lee tanks through Lend-Lease, beginning in early 1942. Soviet crews gave the tanks mixed reviews that reflected both the vehicle's genuine limitations and the different demands of the Eastern Front. Soviet tankers appreciated the 75mm gun's high explosive capability. They found the armor protection adequate by early 1942 standards. The radial engine proved reliable in cold weather when properly maintained, but the tall silhouette created serious problems on the open steppes. German anti-tank guns could acquire M3s at ranges where Soviet crews could not effectively return fire. The limited traverse of the hull mounted 75mm gun made defensive operations difficult. Soviet tank tactics emphasized mobility and flank attacks. The M3's configuration favored deliberate, set-piece engagements. Soviet sources record M3 Lees in combat through the Battle of Kursk in July 1943. After that date, surviving vehicles transferred to training units or secondary theaters. The Soviets preferred their own T-34, which combined a 76mm gun in a proper turret with sloped armor and lower silhouette at roughly the same weight as the M3. The M3 Lee taught American industry how to build medium tanks at scale. The production techniques, assembly methods, and quality control procedures developed for M3 manufacturing transferred directly to the M4 Sherman program. Factories that had never produced armored vehicles learned their trade building M3s. The Continental R975 engine, a 9-cylinder air-cooled radial derived from aircraft designs, powered both the M3 and early M4 Shermans. Experience operating and maintaining this engine in the M3 informed design improvements incorporated into later production. The 75mm M3 gun, mounted in the M3 Lee's hull sponson, became the primary armament of the M4 Sherman in its turret. Crews trained on M3 tanks transferred to Shermans with familiarity in ammunition handling, gunnery procedures, and maintenance requirements. The M7 Priest self-propelled howitzer used the M3 chassis to create one of the war's most effective mobile artillery platforms. The combination of tracked mobility, armored protection for the crew, and a 105mm howitzer gave American infantry divisions unprecedented fire support capability. Over 4,400 M7s were produced. The M3 design's vertical volute spring suspension system, developed from earlier American tank designs, proved reliable enough to warrant continued use on the Sherman. The bogie assemblies could be serviced in the field without specialized equipment. Track links were interchangeable across production variants. Spare parts logistics, the hidden factor that determines whether armored formations can sustain operations, functioned smoothly because the M3 had established the supply infrastructure. 6,258 units produced in 20 months. Combat service on 3 continents. The first Allied tank with a gun capable of matching German armor, a design so urgently needed that engineers accepted compromises they knew violated sound practice. The M3 Lee was never supposed to be a great tank. It was supposed to be a tank that existed when tanks were needed. American industry delivered exactly that. While German production struggled to build a few hundred Panzer IVs per month, American factories produced M3s by the thousand. While British tank design stagnated around inadequate 2-pounder guns, American engineers mounted a weapon that could actually destroy enemy armor. The numbers tell the story. At Gazala, 167 Grants faced 330 German tanks and inflicted losses the Afrika Korps had never experienced from British armor. In Burma, 1,700 M3s dominated Japanese forces for 3 years. 600 M3s fought at 2nd El Alamein, the battle that began the destruction of Axis forces in Africa. The M3 Lee was ugly, the M3 Lee was tall, the M3 Lee was a compromise built in desperation, but the M3 Lee worked. It fired 75mm shells when Allied tanks needed 75mm shells. It arrived in Africa when tanks were needed in Africa. It fought in Burma when tanks were needed in Burma. American engineering excellence does not always mean elegant engineering. Sometimes it means recognizing that a working solution today defeats a perfect solution that arrives too late. The M3 Lee embodied that principle. While other nations struggled to field adequate armor, American factories produced 6,258 medium tanks in less than 2 years. Those tanks changed the balance of power in North Africa. Those tanks held the line until the Sherman arrived. Those tanks proved that American industry could arm the world. The engineers who designed the M3 Lee knew they were building something imperfect. They built it anyway, as fast as they could, because the alternative was watching the Allies lose the war for lack of armor. That willingness to act, to produce, to deliver something that worked rather than waiting for something perfect was its own form of genius. The M3 Lee did not win World War II, but it held the line until the weapons that did win World War II could reach the battlefield. Sometimes that is exactly what victory requires.